Simulating induction heating systems involves lots of time, effort, and the science has to be just right. When running induction simulations, engineers need to be able to model a range of different scenarios and variables to put a design workpiece through its paces and make sure all the bases are covered to ensure consistency of quality in the production process. Today, I'll demonstrate how to do an accurate induction design in 5 minutes using the CENOS induction heating platform. In a few steps, CENOS provides you with an accurate prediction of temperature and magnetic field distribution, and a clear view on power supply requirements and efficiency coefficient, all beautifully visualized in graphics and video that's easily shared with your teammates. Let's take a look at how it works. CENOS is a desktop application for Windows. Once the software is installed on your computer, it's super easy to get started. Open the application, and on the home screen you'll see there are 3 phases to doing a CENOS simulation: pre-processing, computing, and post-processing. I'll click here to set up a new simulation. There are a couple different ways to do a simulation. You can choose from an existing template, build your own geometry from scratch, or upload your own CAD files. Today, we're going to model from an existing template for a frequently used workpiece geometry. The first thing we do is choose our base units. In our case, we'll choose millimeters. Then we choose the desired geometry from one of the existing templates. In this case, we select a stepped shaft and we specify the dimensions. And again, if you need to model a more complex shape, CENOS enables you to define a customized shape or upload your CAD files. Here we define the inductor shape. Let's choose a rectangular profile and define the inductor dimensions and number of windings. And when done, we click the Go to Physics button. Next, we define the parameters of the induction treatment, things like frequency and heating time, and type of material. It's important to note here that CENOS simulates full nonlinear properties like BH curve, which contributes to an accurate prediction of heating results. And lastly, we specify the electric current. And for now, let's leave air at the predefined default settings. So you can see that setting up an induction simulation on CENOS really does take less than 5 minutes. So now let's click the Run button to initiate the simulation. Computing time ranges from a couple of minutes to several hours or even longer, depending primarily on 2 factors. First, it's the complexity of geometry, and secondly, it's the heating time. For example, complex geometries from a CAD file may even require an overnight simulation. In our example, simulating a step shaft from a template should take about 20 minutes. So it's been about 15 minutes and we're about to see results. And there you have it. Boom! The results are beautifully visualized, and note that these are active graphics so you can drag and move the 3D rendering. In this particular case, you'll note in the cross-section view the blue area on the edge below the step. This may be a potential failure point, as you can see the area clearly did not get heated sufficiently to cure the metal. So you may want to run another simulation with, for example, a lower power frequency to more deeply penetrate the metal in the simulation. So this should give you a feel that how CENOS really empowers you to quickly and easily simulate different types of hypotheses so you can get the results you're looking for. Note also that the full power consumption data is logged in an Excel, so you can see the energy economics of your simulation. So if you're an induction heating professional, and maybe you're still doing manual calculations or using simulation software like ANSYS or Flux, which can be very expensive, and you'd like to run complex induction simulations quickly with rock-solid science and crystal-clear results, the CENOS induction heating platform is the right solution for you. To learn more, click the link below to find examples of various simulations that have been run on the CENOS induction heating platform. Thanks for watching.